Hello, grade 8s. Here's our first YouTube video during this pandemic. And we'll be going over what we learned in Chapter 7. So this says 8, but for us it's Chapter 7. Volume of prisms and cylinders. So these three shapes is all that you needed to learn how to find the volume of. And we had our basic formula for volume. I actually want to make my pen a little bit thinner if possible. Okay. Our formula for volume is equal to area of base. This is still too thick. Multiplied by height. I'm going off the page. Multiplied by height. I need this cylinder. There we go. Okay, and so we can use this same equation we can use, area of base, yikes, times by height, we can use for all three of our shapes. So both for our triangular prism, our rectangular prism, and for our cylinder, we use this equation. Now it looks slightly different for each. So here on this nice photo, we have the bases of each. So the base of a triangular prism is this triangle. So the base of a triangular prism is a triangle. The base of a rectangular prism is a rectangle. And the base of a cylinder is a circle. And so you need to find the volume of these shapes, you need to find the area of those bases, so the area of that shape, whatever shape it is that makes it what it is. So if it's a triangular prism, you find the area of the triangle. If it's a rectangular prism, you find the area of a rectangle. Now every side is a rectangle, so it actually doesn't really matter which one. And then for finding the cylinder, you find the area of the circle. And then you multiply that by our height. And so in these cases, the base is always on the bottom. That won't necessarily be the case. You could imagine this cylinder turned on its side, but the bases would still be the circles. So triangular prism, the height is the distance between the two triangles. Now when we look at the rectangular prism, the height is the distance between those two same rectangles. So if you did end up using the side as your base, you could do that, but then you would just have to use this measurement here, which would be your new height, the distance between that face and the other face that is just like it. But in this case, the base is on the bottom, the height is going along here, and our circle, the height of the cylinder is just the length of that cylinder going from circle to circle. And so we can use that equation. Now when we break it down, we can actually get three different equations for each one of these shapes. So we know the triangular prism, the volume would be, well, the area of the base is base times height divided by 2. Base times height divided by 2, that is the area of a triangle. Now this is a little bit confusing because this is the area, here's the area of our base. In our equation, we have to times that by height, and so we can write multiplied by h. And now we have these two h's. We have the h that is in our equation for the area of a triangle, and we have the h that is the height of our prism. It's a little bit confusing, but you just have to make sure you know what you're talking about as you write this. This height in our area formula, we're actually looking at how tall is that triangle, what is its height there, and what is its base of that triangle, of that just two-dimensional shape. And then when you know that, you put that in there, and then you're using this height as that measurement, the height of the actual prism. Okay, your volume of your rectangular prism. Well, to find area of a rectangle, you can do length times by width. So length times by width. And then we're multiplying that by the height of the prism. So length times width times height. You just find the three different direction of sides. So if you find one vertex, one corner here, there will be 3 sides coming off of that. You take those 3 measurements coming off of that one corner, and you can multiply them all together, and that will give you the volume of your rectangular prism. And for our cylinder, when we have a circle as the base, the area of the base, well, the area of a circle is pi r squared. That sounds like area to me. And then we multiply that by the height of our prism. And so these are 3 equations, the 3 basic equations that we've been looking at. So this is for your cylinder. Cylinder? That's how you spell it? Oh yeah, it's up here. This is for your rectangular prism. Don't even need to write it out. And this is for your triangular prism. Okay, so those are our 3 equations. But again, all 3 of these equations just come from this basic equation that volume is equal to the area of the base times by the height. So we can use that for any 3 of these shapes. Let's go to the next page. So here we have some quick examples. Ugh, can you see this? Probably. You guys have good eyes. So this is a 6. This is a 7. This is a 10. 10. 5. 20. 10. 5. Okay. So if we are trying to find the volume of these, I look at my first rectangular prism. I know volume is equal to base, area of base times by the height. So in this case, the area of the base, I could look at the bottom rectangle here if I wanted to, is 6 times by 7. 6 times by 7 is equal to 42 centimeters, and then we're multiplying that by the height of our rectangular prism. So volume equals length times width times height. Well, that's equal to, the length is, we can say 6 or whatever. Width is 7. Height is 10. 6 times 7 is 42. 42 times 10 is 420 centimeters. Now, what is our unit? Centimeters cubed, because we've gone centimeters times by, centimeters times by centimeters times by centimeters again means that we end up with centimeters cubed. Let's quickly look at our triangular prism. For the volume of a triangular prism, we said it's base times height divided by 2 is the area of a triangle. And when we find that area of that triangle, we multiply it by the length of the prism and the height of the prism, height or length. And now we can just enter this in. We have this equation. So the base of my triangle is right here. That's the base of my triangle. It is 10 centimeters. The height of my triangle is 5 centimeters. So I multiply that by 5 centimeters. And then I divide that by 2. And then I'm timesing that. The height of the prism we know is 20 centimeters. Okay, so to break this down, 10 times 5 gives me 50 centimeters. Now I also want centimeters times by centimeters, so that's 50 centimeters squared. And I divide that by 2. The 2 doesn't have any units, so it stays centimeters squared. And I'm still timesing that by 20 centimeters. So volume is equal to, well, 50 divided by 2 is 25 centimeters squared times by 20 centimeters. So now I have the centimeters squared times by centimeters. I'm still going to have 3 of those centimeters because centimeters squared is 2 of them. And then another centimeters is going to make centimeters cubed. 25 times by 20. Now how could you do that? Well, I would think 25 times by 2 I know is 50. And then I add on this other 0 to get 500 centimeters cubed. Oh, excuse me. That's just a regular, just swallowed wrong cough. Okay, no worries. Okay, and let's move over here to our cylinder. So again, we said volume is equal to the area of the base. The area of the base for a circle is pi r squared. And we times that by the height of our cylinder. So now we have just 2 variables that we need to fill in. So we know pi is 3.14159. You can just use 3.14. The radius it shows here is 5, so we have to go times by 5 squared. And we times that by the height of the prism between the two circles, and that's 10. So let's simplify this out. Pi times by 5 squared is 25. 5 times 5 is 25 times by 10. You'll now probably need to use a calculator. You could just say pi times by, well, 25 times by 10 is 250. So I know it's 250 times by pi. If I make an estimate, pi is about 3. 3 times by 25 is 75. So 3 times 250 would be 750. But I can put this into my calculator. 3.14 times by 250 equals 785. And this one is again, sorry, we should actually show that since this is centimeters, since it's 5 centimeters being squared, it's 5 centimeters times 5 centimeters, which gives us 25 centimeters squared. And then we're timesing that by 10 centimeters. So 25 centimeters squared times by 10 centimeters gives us centimeters cubed. So the units always work out as well, which is good evidence that we did it correctly, that we had centimeters being times together 3 times. Okay, so these are the answers. I did lots of steps for these. I don't expect you, like over here with finding this triangular prism, I don't expect you to show all of these breakdown of the steps. I was just doing that to explain how you solve it and in what order you solve it. But if you want to skip a couple of those, that's fine. But again, for each of these, we just had that basic formula is volume is the area of the base. Find the area. Whoa. Find the area of the whatever the base shape is, and then you multiply by that by how far that shape is being stretched out to its other side. Okay, let's go through this a bit quicker maybe. Here we have a shape. We have a rectangular prism, and it has this triangular hole cut out of it. And so now again, we can just think of that basic formula. Volume is equal to area of base, timesing that by height. Now in this case, the area of our base is a bit of a weird shape. It's this rectangle with the hole cut out of it. In which case, we could actually just find the area of the rectangle and subtract the area of this triangle, and that would give us the area of the top here, which then goes all the way through to the bottom face, which is the same. And so here would be our height, and here would be, on top here would be the area of our face. So let's do that. Let's find the area of the rectangular base would be length times by width. Well, we know that the length is 36 centimeters, shows here, and the width of this, when we're imagining this top rectangle, the two sides is 36 centimeters by 30 centimeters. So times that by 30 centimeters. You'd probably want to use a calculator for that one. 30 times 36 is 1080. 1080, and we want centimeters times centimeters, so that's centimeters squared. So that's the area of our rectangle. Now let's find the area of this triangle here at the top that we're going to have to subtract from the area of that rectangle. So I know the measurements here are a little bit confusing, but this 20 centimeters is really showing how tall that triangle is, and so that's the height of our triangle. And so the area of our triangle would be base times height divided by 2. Now remember, I'm talking about area here, not volume. So base times height divided by 2, just looking at the area. So the base of the triangle is 15 centimeters. We multiply that by the height, which is 20 centimeters. And then we divide that by 2. But I have centimeters times centimeters, so my final units will be centimeters squared. And 15 times by 20 is equal to 300 centimeters squared. And again, I would think 15 times by 2 is 30, and then I have to add that 0. If I was doing it in my head, you can use your calculator for this. Okay, and so I have 300 centimeters squared is the area of that triangle. Now to find the volume, knowing that volume is the area of the base times by the height. Whoa. There we go. Times by the height. Well, what is the total area of the base? Well, the area of the base is equal to 1080, the area of that rectangle, minus the 300 centimeters squared, which is that missing triangle, which is equal to 1080 minus 300. I should be able to do this in my head. Is 780 centimeters squared. Okay, so that's the area of the base. And now we need to times it by the height. So now we know that that 780 centimeters squared is how much this takes up, this space takes up without that triangle there. And since that's continuing all the way through the shape, we can just times that. The volume is 780 centimeters squared times by, where's our height? Over here, 6 centimeters. We get centimeters squared times by just a one-dimensional centimeter, and so we're going to end up with 2 of them here, 1 of them here. We just don't show that little one, but there's an imaginary one there, and so it's centimeters cubed. The volume is equal to 780 times by 6. Whoops, I can just do that on my calculator. 780 times by 6, 4,680 centimeters cubed. The units worked out. Seems like a reasonable answer. There's our answer for the volume of that shape with that triangular prism missing. Now again, you could actually have just found the total volume of the rectangular prism and then subtracted the total volume of that missing triangular prism. That works either way. I was just showing this way where I just find the area of the base and then multiply by the height. One more example, because this is probably already like way too long for people that actually want to watch the whole thing. Here, a clay planter has the shape of a right triangular prism as shown. Inside the planter is a cylindrical hole. That's where you'd put the dirt and plant your flowers. Calculate the volume of clay needed to make the planter to the nearest tenth of a cubic meter. So there's lots of numbers on this diagram, so we need to figure out what we need. Now in this case, knowing that, you know, our equation for volume, hey, don't be a thick line. Our equation for volume is area of base. I always like to write that down and then figure out what the area of base is, times by height of the prism or cylinder. Now since this cylinder here, it doesn't actually go all the way through. So I can't find just the area of this leftover triangle piece with that circle gone and multiply it by that total height, because this circle does not go all the way through. So the best way to solve this one would be to say, okay, well, what would the volume of this triangular prism be if it was totally solid? And then let's take away the volume of this cylinder inside it. So we're just going to find the volume of those two shapes separately, and then we'll subtract them. So the volume of our little triangular prism, let's draw that little diagram there. Whoop, tiny little prism. What units do I need here? So the area of the base, I know, is base times by height divided by 2 is the area of a triangle. Base times height divided by 2. And then timesing that by the height of our shape. Okay, well, let's find the numbers that we know, that we need. So the base of the triangle, okay, that's right here. If I look at the measurements for the triangle, it's 0.4 meters. If you guys want to, you could pause this quickly and try to do it yourself and then see if you get the same answer as me. That'd probably be a good way to see if you're understanding what we're doing. So you can do that, pause it, try to find the answer, and see if you do the same thing as me. So 0.4 meters is the base. The height of our triangle is given here. Right there is the height of the triangle. So we're timesing that by 0.35 meters, and that's going to be divided by 2. Now we still need this multiplied by the height. The height of the triangular prism is the whole way along which is signified by that measurement. So times by 1.4 meters. So again, look, we have meters times by meters times by meters. That's going to give us meters cubed. So that's a good sign that we have the right number of meters in here. It's always good to write your units. Now I can solve this. Volume is equal to, well, I'd take my calculator and I would do 0.4 times by 0.35, which is equal to 0.14. Now don't let this surprise you. So 0.4 is less than 1, 0.35 is less than 1, and 0.14 is smaller than each of these numbers. That makes sense because when we're multiplying decimal numbers, numbers smaller than 1, we're actually saying we don't even have 1 whole of 0.35. In fact, we have less than half because 0.5 would be half. So it makes sense that we're getting 0.14. So that makes sense to me. Meters squared because it's meters times by meters, dividing by 2, and then we're still timesing by 1.4 meters. Okay, let's do the next step. Again, if you want to do steps a bit faster, you can, but the next step would be go 0.14 divided by 2, which will be 0.07 meters squared. Okay, so I just did that next step, and then I'm timesing that by 1.4 meters. And then I can times that, multiply by that on my calculator, times by 1.4. And I get this pretty small number. 0.098 meters cubed. Okay, so sometimes you look at this and it's easy to think that it's sort of confusing that this number seems so small, but remember, think of what a 1 meter cubed is. A meter by meter by meter box sitting in front of you. That's a pretty big box. So it makes sense that this planter could be much smaller than 1 meter cubed. So as much as it seems like a small number that, you know, maybe you wouldn't expect that, it actually does make sense. So here's the volume. Remember, this is just of our triangular prism. Okay, now we need to find the volume of our cylinder, and we need to subtract that from this answer. So this is one answer that we're going to need. Now let's find the volume of the cylinder. So the volume of the cylinder, so the area of the base of the circle is pi r squared times by the height of the cylinder now. So this is the volume of the cylinder. Okay, so I enter in the missing variables. Pi, I know, is just a constant. It's 3.14 times by r squared. So the radius is, well, if the diameter is 0.25, the radius would be half of that. So 0.25 divided by 2 gives me 0.125 meters. Okay, so times by radius squared means radius times radius. 0.125 times by 0.125 times by, well, what's the height of this cylinder? Well, this only goes 1 meter down, times by 1 meter. Now I can just enter this into my calculator. I can go 3.14, that's pi, times by 0.125 times by 0.125 times by 1, which gives me 0.049, I'll just leave it there, meters cubed, because this is meters, so meters times by meters times by meters, so meters 3, meters cubed. And here's my two answers. And so now I can just subtract these. I'm finding my volume of my triangular prism minus the volume of my cylinder would give me my final answer, which is equal to 0.098 minus 0.049, and do that on my calculator. 0.098 minus, wait, this is going to be 0.049, same thing, 0.049, yeah. 49 is half of 98, so the answer is 0.049 meters cubed of clay that you'll need to make that triangular part. The question does say the nearest tenth of a cubic centimeter, however, though. Ooh, I just found it in meters. This is interesting. So when you need to make this conversion, we know, and this is a tricky part. So maybe you didn't find it in centimeters. You have a couple options. You could initially change all of these meters here to centimeters. So this would be 40 centimeters. That probably would have been a smart thing to do. This would be 35 centimeters. This would be 140 centimeters, because there's 100 centimeters in every meter, so we'd be timesing each of these meters by 100. 1 meter is 100 centimeters. It's a good place to start to know if you're having to multiply or divide by 100. And 0.25 times by 100 would be 25 centimeters. So if we converted all of these first and then did our equations, that would have been one way that we could have gotten the correct answer. But I just want to quickly go over how we can do a conversion from something like meters cubed to centimeters cubed. So let's quickly go over how we do that. I like to think of it this way. If I have, can I extend the page? If I have a cube, and this cube I'm going to say is 1 meter by 1 meter by 1 meter. So these are the 3 different measurements coming off of this corner here. So they're the 3 that I'd be multiplying together. 1 meter by 1 meter by 1 meter. What's the volume of this cube in meters cubed? Well, the volume would be 1 times 1 times 1, which is 1 meter cubed. But how about this volume in centimeters cubed? When I look at this 1 meter as centimeters, that's, we already talked about, is 100 centimeters. This 1 meter is 100 centimeters. And this 1 meter is 100 centimeters. And so what's the volume in terms of centimeters? Well, the volume would be 100 centimeters times by 100 centimeters times by 100 centimeters. So it's not, the conversion of meters cubed to centimeters cubed is not the same as the conversion from centimeters to meters, which we said is 1 meter equals 100 centimeters. 1 meter cubed does not equal 100 centimeters cubed. It equals 100 times 100 times 100 centimeters cubed. So 100 times 100 times 100 gives me 1 million. So there's 1 million centimeters cubed in this 1 meter by 1 meter by 1 meter box. And so here's our conversion. 1 meter cubed is equal to 1 million centimeters cubed. And so if we have 0.049 meters cubed, how many centimeters cubed would that be? Well, I had to multiply by 1 million times 1 million to get from 1 meter cubed to centimeters cubed. So from meters cubed here, I multiply by 1 million. Multiplying by 1 million moves the decimal place over 6 times, but you could also just enter in 0.049 times by 1 million into your calculator, and you get 49,000. I probably should have kept more decimal places in there to actually find it to the nearest 10th centimeter, but there we go, centimeter cubed. And there's our answer. So I'm guessing a lot of you got to this answer if you were keeping it in meters. Ugh, my writing is very messy. If you're keeping it in meters, you probably got to that answer. Doing this conversion would have been the next step to find it in centimeters cubed. Again, if you just convert early, you could convert every unit in this question into centimeters and then just solve it with centimeters, and that would give you the same answer. Or you can figure out the conversion from meters cubed to centimeters cubed and use that to find the answer. So that's the end of the video. This is way longer than I wanted it to be. I'm going to have to use less examples next time. Hopefully you watched it. Do try to do them by yourself and do the assignment that I'm going to be putting online as well. And talk to you later. Bye. Oh, wait, how do I stop recording? Here we go.